Okay, we get a second day at simplifying radical expressions. This is 4.5, day 2. We're going to look at radical quotients. Quotients are fractions, so that's what we're looking at today. There are some rules about radicals with fractions. Okay, this was our homework quiz for today. We were looking at simplifying radicals that weren't quotients from yesterday. And so we had students tell us the correct answer. If you're at home, pause, try this, come back and check your work. And if you're back, the correct answers are shown. There you go. Okay, so hopefully you're strong there. And now today we are simplifying radicals still. We're going to continue that, but now with fractions. So there is a property called the quotient property of square roots. And before we write the actual rule, which involves variables, let's try a sample. The square root of this fraction, 23/36. 23/36. So, just like yesterday, when we took, let me go to what we did yesterday and you can see. We took square root of 36, remember? And we wrote it expanding it, really, right? Let me see. This won't let me grab it. Okay, grab it this way. We expanded things, right? We said the square root of 36 could be the square root of 9 times 4, which are factors of 36. And then look at that, we separated the factors into their own radicals. But the operation was still multiplication between them. And we said these are all equal, okay? We can do the same thing with our quotient. So instead of writing this as the square root of the fraction that you see, 23/36, we can separate the numerator and the denominator. The square root of 23 over the square root of 36. These are equivalent expressions. And it's nice to separate them because one of them is a perfect square, right? What is the square root of 36? And so we can write this now as square root of 23 over 6, which is no longer in the radical. A fraction is not simplified if there is a radical in the denominator. You may not have a radical in the denominator underneath. Just like what number may never be in the denominator? 0. Under may never have 0, right? So this is now a simplified radical expression because the square root of 23 is not simplifiable, really, right? 23 is not a perfect square number. So there you have it. Okay? As a rule, we use variables. So how do you think we can show the square root of a over b now in this rule? Is it? Good, so we kind of separate them. Why won't this let me do that? Wow, this is just, that is correct. So this says the square root of a over the square root of b. And as we just said, what number may never be in the denominator? 0. So we would have to say that b may not equal 0 because the square root of 0 is 0. So b has to be greater than 0. Also, a needs to be this, and we saw that yesterday too. Who remembers why a must be greater than or equal to 0? It must be greater than or equal to 0 because, Teddy? Right. If it's a negative, you can't have a negative in your radical, in your square root, because we can't find a square root of a negative number. It's not real. It's actually imaginary. Isn't that interesting? So when you get further in math, you will use imaginary numbers. Isn't that interesting? So the definition of an imaginary number would be like taking the square root of -1. That equals the imaginary number. And the square root of -1 isn't something we can really say, right? We said yesterday negative 1 times negative 1 is 1. And 1 times 1 is 1. So we can't find a square root of negative 1, but could you imagine multiplying two numbers together and getting negative 1? Can you imagine it? Yes. And actually, you want to see which numbers you could do? Or can anybody tell me what two numbers we could multiply together to get negative 1? Spencer? Oh, but they have to be the same number, right? It would have to be, well, you're right. You answered my question, actually. But we need to have a number that when squared equals negative 1. A number times itself, which equals negative 1. Brian? Negative 10 to the 0 is just equal to, anything to the 0 is 1. Well, it has to be the same number in itself. You want to see it? It would be taking the square root of negative 1 times the square root of negative 1, right? And so we could write that as what? Who remembers? We just did this. We could write this as negative 1 times negative 1, right? In the radical. And what is negative 1 times negative 1? So we have the square root of 1, which equals 1. So if we take the square root of negative 1 itself, the whole thing, and square it, we get, what do we get? Actually, we get negative 1. The square root and the squaring are inverse operations. Isn't that interesting? You're squaring the square root of negative 1 and you get negative 1. It's kind of interesting. Strange imaginary numbers. Okay, let's try this. Let's try simplifying these radicals that are fractions. And I'm going to bring up some volunteers to do this. So how about, go straight down, please, because we need to save room. And thumbs up if you agree. Very good. So the denominator is a number that is rational. Pull it out of there. And the next one, okay, Ryan. Square root of 2/9. And thumbs up if you agree. Square root of 2 over 3. Good job. Ryan, you can select the next person. If you put your left shoulder toward the board, it's easier. Reach across. There you go. Excellent job. Good. Okay, so you have the hang of this. Of course, you're going to see some bigger numbers there. Okay, it's possible. This is a bonus question, and it's really tricky. Who could answer this one? And you have to recall something I said really early on about fractions with radicals. What did I say? Must be true with radicals and fractions. Do you remember what I said, Jake? Okay, Aiden?
Whatever you do to the bottom, you have to do to the top.
Okay, well, that's the case with most fractions, I suppose. But I said something really special here. Brian? What may you not have in the denominator? Okay, a radical. So right now, when you start simplifying this, you have to make sure your answer does not have a radical in the denominator. So it makes it really tricky. Who wants to try? Okay, so we have expanded things a little bit and seen that we could take the square root of 9, which is 3, but now we have a radical in the denominator. So how can we get that out of there? This is an advanced topic, super extra credit for the person who can tell me. Izzy? Well, she says, can you go 3 over the square root of 2 times 5, right? That's still 10, but that didn't remove the radical. We still have a radical there, so keep thinking. What do you think? Well, except that we don't know exactly what the square root of 10 is. It's an irrational number, so it goes on and on forever. We could estimate it, right? We could say the square root of 10 is about 3.1 or something, but 3.2. But when we are simplifying radicals, we do not estimate. We do not round a number. We actually leave things in a radical, but the radical may not be in the denominator. So, Spencer, you just switch it randomly? Is that fair? Is that fair to take a fraction like, Spencer, can I just take 1/3 and now call it 3 over 1? Yeah. Is this true? No, it's not true. No. What are we going to do? We need a fancy technique here, something advanced. Audrey? By what? What do you mean? Multiply by, you do need to multiply. You need to blow this thing up. You need to blow this fraction up. What can you use to blow it up that will get rid of that radical? Caitlin? Over 100? How do you make it 100? How do you make the 10 100? Lauren?
Well, you have to like multiply by the square root.
Awesome. Did you hear Lauren? She said multiply by the square root of 10. And if you do that, what do you do to the numerator too? 7th grade listening.
Did you turn it back into
What do you have to multiply the numerator by 2?
10?
Square root of 10. I hear a few people saying it. So this is just blowing up a fraction by multiplying by 1, right? Square root of 10 over square root of 10 is 1. It's a special 1 that we chose so that in the denominator we have, let me put the numerator, right? In the denominator we have really square root of 10 times 10, right? And what is the square root of 10 times 10? 10. It's the square root of 100, which is 10, right? So we can now call this 3 times the square root of 10 over 10. Now there is no radical in the denominator, and so this is the simplified fraction. Isn't that cool? You can multiply by a radical in order to get rid of a radical. It's very, very advanced. Okay, here you go. You may begin and complete it while you're here.